All right, so here's the third video on the actual procedure that we'll take to determine the order of hydrogen peroxide. First of all, here's a nice image of the burette in all its glory, the funnel on the top. It has been pre-filled with the permanganate ion. It comes in the form of potassium permanganate, but potassium spectates, so we eliminate it from the reaction. Notice it's purple, as earlier you had heard it would be. It is a 0.200 molar solution of potassium permanganate or permanganate, 0.200 molar, which you already have recorded for you in your raw data table. I made this solution by using a volumetric flask, which is a device that is used to make a solution of a very specific volume. In this case, it's 500 milliliters. I had a stock solution of permanganate that was 0.1 molar. I needed to dilute it to 0.02 molar, so I did a little bit of calculation. It's a 4-to-1 dilution. I put 100 milliliters of distilled water in here, and then I put 100 milliliters of the 0.1 molar permanganate in here. I added enough water to get to the 500 mil line, which was 400 mils, and that gives me a very accurate volume of a 0.02 molar permanganate solution. Again, that's been added to the burette already. Here I've got iron 3 nitrate. It's 10 milliliters of iron 3 nitrate. I'm only going to use 6 milliliters of it. This is a catalyzed reaction. Hydrogen peroxide decomposes very slowly on its own. It takes many, many years for liquid hydrogen peroxide to turn into water and oxygen gas, which is good because otherwise if we bought it, it would go away immediately. But if you add iron or other catalyst to it, it decomposes much more rapidly. So we need a catalyst for the reaction to happen fast enough for us to actually meaningfully observe it. I have got 6 Erlenmeyer flasks that are pre-filled with 50 milliliters of water. That's just going to dilute my titrant flask, as soon as you analyte flask a little bit better. And then I've got some concentrated sulfuric acid. I'm going to put my goggles on for this. This is 18 molar, really nasty stuff. I've got to acidify my reaction flasks so the reaction happens properly, so that the permanganate ion turns into the manganese ion instead of manganese dioxide, solid manganese dioxide. So it's a lay of the land here. So again, I've already filled my burette with permanganate. I'll get the initial reading here in a moment. I'm now going to acidify each of these reaction flasks by adding a half a dropper full of concentrated sulfuric acid. So I'll do that right now, and then I'll be right back. All right, so I've got half a dropper full of the concentrated sulfuric acid in each of these reaction flasks. I've just added 6 milliliters of the catalyst iron 3 nitrate to this graduated cylinder, so I'm ready to pour it into my hydrogen peroxide. The moment that I pour the catalyst in, the clock starts ticking. I've got a stopwatch over here that I'm going to hit start on the moment I add the catalyst, because that's, again, time equals 0. I need to get an initial reading off my burette. So please write down, I'm going to go with tenths here, because you're going to find that the experiment happens fast enough, it's hard to get really accurate readings, but it's going to be 0.5 milliliters is the initial volume of the permanganate ion at time equals 0. 0.5 milliliters of permanganate at time equals 0. Okay. All right, here we go. About to hit start, about to add the 6 mils of iron 3 nitrate to the hydrogen peroxide. So the reaction begins. Ready, set, go. Okay, time is ticking. There we go. I've now got a disposable pipette that allows me to dispense, measure accurate volumes of liquids quickly. It is 10.0 milliliters of the hydrogen peroxide that 6 different times I'll be sucking up. There we go. Put in my Erlenmeyer. Again, it's 10.0 milliliters of peroxide 6 times. All right, ready to start titrating. So remember, as I add the permanganate, because the peroxide is still in excess, it should be reacting with all the permanganate. It should go to colorless. And as I add and I swirl, it, in fact, you can see, is pretty rapidly becoming colorless. I'll let her go. Now, earlier you heard me say that we see the color persist where it's being added, and that's the case. When that persistence starts to stick around a little longer is when we know we're getting closer to the equivalence point, the point at which moles of peroxide equals moles of permanganate, at least from a stoichiometric standpoint, based on the coefficients. Pink is sticking around a little longer. Taking longer as I swirl it for the pink to go away. It's taking even longer. So notice spurt. I'm doing this quickly because I'm on the clock. Ooh, look at that. It's taking a while to go away. I think we're getting close. All right. I'm going to now add just a bit at a time. Little spurts. And voila. One tiny spurt and it stayed pink. All right, so my final volume is 38.2. Final volume, trial 1, 38.2. Clock's at 2:30. I tend to want to wait until minute 6 or 7 for my second run, so my data points get spread out, so I can relax for a bit, get my second flask ready for my second titration about minute 6 or 7. Small snafu with software, so it's been a little bit longer than 6 or 7 minutes, we're still okay. I refilled my burette with the permanganate so that I've got enough for the second run. I'm going to give you the initial reading right now. It's often easier with a piece of white paper behind it. This is looking at 10.7 milliliters for time 2, and I'll tell you what the time to in a moment. I'm going to give it to you in minutes and seconds, but you'll need to convert it mathematically to just seconds. All right. We are ready to go. 8 minutes and 37 seconds is the beginning of run 2. Here we go. There's my 10.0 mils. Put it in my reaction flask. Because the reaction has been proceeding, we should expect the concentration of peroxide to be going down, which means a lesser volume of the permanganate ion should be needed to reach the equivalence point. And here we go. Pink's starting to stick around a little longer, getting closer, little spurts. Oh boy. Oh, come on, little buddy. I'm tired. And, oh, one more. Boom. All right. That's our final reading. 37.7. 37.7. So another 6 or 7 minutes elapses. Trial 3 happens. 6 or 7 more minutes. 4, then 5, then 6. I won't make you stick around for those. I'll do those on my own, and I'll come back at the end and give you all those values, the times and the initial and final volumes of those last 4 runs. All right, I made it. 4 more runs. So the third run, the time, I did it for you in seconds, is 967 seconds. Initial volume of 4.5, final of 24.5. For the fourth run, the time in seconds, elapsed time again, total elapsed time 1434 seconds. Initial volume 8.2 milliliters, final volume 22.9. Fifth run, 1967, elapsed time 6.9, initial volume 17.6 final. And the final run was 2,389 seconds after I hit start, initial volume 7.1, final volume 15.0. Enjoy answering your questions and doing some calculations and some graphing. I will see you on the other side. Good day, folks.